Alright guys, today we are looking at solving linear equations that have fractional coefficients or have fractions in general. The steps from our first video on solving equations still apply. If there's parentheses, you need to get rid of them using the distributive property. You want to make sure that you move everything away from the variable. And today we're going to get rid of fractions. So when there's multiple fractions, you want to find the lowest common denominator and use that to help get rid of them. When there's one fraction, like it is in example 1, we will take a different approach. If you look at example 1, it's negative 6 plus x divided by 5 equals negative 3. So what we're going to do is we're going to treat this as one piece. That's our x piece. Remember, if something's attached to x, we move it second. So what we're going to do is not worry about what's circled in red. We're going to move the negative 6 first. So to move negative 6 over to the right side, because negative 6 is not attached to x, we're going to go ahead and add 6 to both sides to move it over. The 6's will cancel out. On the left-hand side, I have x divided by 5. And on the right-hand side, I have negative 3 plus 6. So that's going to be a positive 3. Now I need to get rid of that 5. So right now it says x divided by 5. So I want to get rid of division by multiplying. And I'm going to multiply both sides by 5 so that on the left-hand side, the 5's cancel. And I have x. And on the right-hand side, I have 3 times 5 is 15. There's my answer. Okay, pretty straightforward. We're going to go ahead and look at example 2. Example 2 is x divided by 18 plus 9 equals 10. Again, I'm going to treat x divided by 18 as one piece. 18 is attached to x, so I'm not moving 18 first. What I'm going to move first instead is this plus 9. So to move the positive 9, I'm going to subtract 9 from both sides. These 9's will then cancel out. On the left-hand side, I'm left with x divided by 18. And on the right-hand side, 10 minus 9 is 1. So now I need to get rid of 18. Remember, x is being divided here, so to get rid of division, I multiply both sides by 18. So now what I'm doing, once the 18's cancel, I have x equals 18 as my answer. And there we go. Now we're going to move on to our next set of examples. These ones look a little bit different. I have a larger fraction. In the numerator, I have 2 terms for each of these. So remember, terms are pieces of an equation. So if we look at example 3, on the right-hand side of the equation, I have a fraction that has 2 terms in the numerator. So 1, 2. When this happens, I have this large fraction. I'm going to get rid of the denominator, which in this case is 2, first, because I can't move the 4 because it's also being divided by 2. Although it's not directly attached to m, like you would say 4 times m, it's still being divided by 2, so I have to move that 2 first. To move the 2 first, all I'm going to do is multiply both sides of the equation by 2. But I want to make sure I'm multiplying this entire fraction. So I'm going to put parentheses around it. And I'm going to multiply the 4 by 2 as well. When I multiply the fraction by 2, the denominator and this 2 cancel out. And it leaves me with what's up top, which is 4 plus m. On the left side, I have 8. So 8 equals 4 plus m. Now I just have to move the 4 by subtracting it from both sides. in example 4, it's the same thing. I need to get rid of the 4 in the denominator because it's dividing all of b plus 6. So to move the 4, I multiply both sides. Remember, we multiply the entire fraction. I also multiply this negative 1 times 4. So on the left-hand side, I have 4. On the right-hand side, these cancel out. Pardon me, on the left-hand side, I have negative 4. On the right-hand side, these 4's cancel, and I'm left with b plus 6. To get b by itself, I simply subtract 6 from both sides. Negative 4 minus 6 is going to give me negative 10. So negative 10 is equal to b. In our last two examples, these look slightly different as well. Now, not only do I have this fraction here, but I also have a number directly attached to x, so 3 times x. We're going to treat it the same way as we did examples 1 and 2, where I'm going to leave this as one piece until I move this plus 6. To move the plus 6, I'm going to subtract 6 from both sides. These cancel. And I have 3x divided by 2 equals negative 6. Now I have to get rid of the fraction. To get rid of the fraction, I need to move the denominator. I need to get rid of the denominator by multiplying both sides of the equation by 2. So I'm multiplying this fraction and that negative 6 by 2. On this side, the 2's cancel, and it leaves me with 3x. On the right-hand side, I have negative 12. Now I'm going to divide both sides by 3 to get x by itself. So x equals negative 4. Same process for example 6. We're going to move this negative 7 over by adding it to both sides. I'm left with 8x divided by 7 equals positive 7. To get rid of this fraction, or the 7 that's in the denominator of the fraction, I would multiply both sides by 7. So that the denominator gets canceled out. And I have 8x equals 49. Now to get x by itself, I simply divide both sides by 8. And I have x equals 49 over 8. And that is solving linear equations with fractional exponent or fractional coefficients.